Welcome to the constant rule. This is a series of videos set to teach you the derivative rules. So this is the very first video in that series, and it starts off with actually one of the easiest rules, the constant rule. So let's dive right into it. First, we need to talk about the different ways to identify a derivative. Hopefully, you've already learned by now, if you're watching this video, that one way to identify a derivative is with what we call f prime. It's actually called f prime. Now remember, f of x and y are exactly the same thing, so we could even just use y, but again, we put this little accent mark that we pronounce prime. So f prime of x or y prime. But another way, or maybe a new way to some of you, or maybe an old way to some of you, is to use this different notation. So basically, it's d over dx. Now that d stands for derivative, but here's what we're saying. We're saying, all right, here is the derivative of f of x with respect to x. Or if we want to use y instead of f of x, we'd say the derivative of y with respect to x. Now, with respect to x simply means that like the independent variable in the problem is x. You need x to actually use the derivative to find the rate of change at any given point. But it's this little bit of a different notation. So basically we have d of x. That's saying, hey, here comes the derivative with respect to x. Then in the brackets is the actual function that you're finding the derivative of. And then you equal, well, the answer, right? So inside the brackets is the function that you're trying to find the derivative of with respect to x, simply meaning there's an x in it. And then next to it is, well, your answer. So it's just a different way that we use to identify derivatives. And we tend to see this notation a lot when we talk about the derivative rules. So here is the constant rule. It's very, very simple, one of the easiest rules out there. The derivative of a constant function is 0. That is, if c is a real number, any real number, and f of x equals c, meaning the function equals a constant, then the derivative of that function is 0. That's it. C is a real number. No variables, just a number, a real number. The derivative of a real number, the derivative of a constant is equal to 0. Now, using our new notation, that is the derivative of a constant with respect to x is 0. The derivative of a constant is 0. Very, very, very simple rule and so easy to use. So what is the derivative of 7? Let's do an example here. So we have 7. What is the derivative of 7? Well, the constant rule says that the derivative of any constant is 0. There it is. Or we could use our new notation, the derivative with respect to x of the function 7 is 0. Either one of those, full credit, makes sense. Now let's talk about y. 7, just the function y equals 7, is a horizontal line like this. And a horizontal line has a slope that never, ever, 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 ever changes. It's always constant. And the slope of a horizontal line is always 0. No matter what point you choose to be on this horizontal line, your slope is 0, which is why the derivative of a constant is always going to be 0. Let's try another one. Hey, what's the derivative of 5? 0. So the derivative of this function, we could use our notation y prime is 5, or we could use our new notation, the derivative with respect to x of the function 5 is 0. It's that easy. Come on. Can't even believe we're still doing more of these. All right, here's another one. What is the derivative of the function s? S prime. Well, -3 is a constant, 0. Or the derivative with respect to x of the function -3 is 0. I mean, it's really the easiest rule. Come on. Even something like this, y equals pi. Pi is an irrational number, but pi is still a real number. So it's a constant. There's no variables involved there. It's a number. So what is y prime? 0. What is the derivative with respect to x of this function pi? 0. I mean, that's it. Such a simple rule. The derivative of a constant, a real number, is always 0. That's it for the very first derivative rule. Stay tuned for the second video in this series. Don't forget to subscribe and like as well. See you later.